decreases. Okay, first we'll speed of as seen by bird directly. Speed of fish as seen by bird directly. The fish is at a depth b minus c. The fish is at a depth b minus c. At what height the bird is at a distance c. First we'll calculate the distances. S1 is equal to at what distance the bird is from the boundary at a distance a. What is the real depth of the fish? B minus c. Apparent depth mu. So therefore the distances will be what do you mean by dot? Derivative, that one. The first order derivative will write like this. Suppose if I write y dot, it is nothing but dy by dt. Okay, fine. To save time, I could have written dy by dt, dA by dt, dB by dt, dC by dt. So we are just writing dot here. The first order derivative we just indicate by dot here. So this will be v1. Now dA by dt, dA by dt. Oh, so, okay, that is, I should take all the references. Sorry, some correction there. All the distances. So there's a reference for this. Definitely, this will also change. I'll bring it again. Huh? Okay, what distance the bird is from the bottom of the vessel? A. What is the depth? What is the level of water in the vessel? B. At what distance the fish is from the vessel, bottom of the vessel? Let it be C. Now, distance of the bird from the boundary A minus B. Real depth of the fish B minus C. Apparent depth mu. What about this? What I'm discussing, the rays emitted by fish will undergo refraction, will enter into bird. That's what directly. Yeah? Now this will be varying. So V1 equal to dA by dt minus 5. dB by dt minus 2. dB by dt minus 2. dC by dt solving this minus 5 plus 2. This will be minus 2, minus 2, minus 2, minus 4, minus 4. This will get cancelled. So this will become, will end up with only minus 3. Minus 5 plus 2 will be minus 3, minus 3, minus 3, minus 6. So minus 6 centimeter per second. Next, speed of fish as seen by bird indirectly. Yeah? So the rays emitted by fish, first it will strike the mirror, it will form an image. Already we have discussed one problem, I need not to repeat here. Then that image will be seen by the bird. So it will be S2 is equal to first the distance of the bird from the boundary A minus B. Then the fish will is at a distance C. First the rays emitted by fish will strike the mirror. It will form image F dash, and the rays reflected by the mirror will undergo refraction, will pass through the bird. So this everything will appear like a liquid for us. So therefore, this will be uh, so how much we should write? B plus C by mu. Already I discussed. Okay, this will be V2 equal to dA by dt minus 5, dB by dt minus 2, dB by dt minus 2, dC by dt plus 2, 4 by 3. Minus 5 plus 2 minus 3 minus 2 plus 2. This will be 0. Okay, this will be the speed of fish as seen by the bird indirectly. Now we'll go for the bird one. Let me finish off this problem here only. Second, third one. Speed of bird as seen by fish. S3 is equal to speed of bird as seen by fish directly. As seen by fish directly. So at what distance the bird is? At a minus B from the boundary. At what distance the fish is from the boundary? B minus C. So this will become mu times of A minus B. Differentiating this, minus 2 plus 2, mu is how much? 4 by 3, minus 5, B is how much? Minus 2. Yes, sir, how you are writing all this? B dot, as the level of liquid falls, so it should be minus 2, no? B will be B dot, rate of change of dB by dt will be negative. The distance C increases, so dC by dt of C dot should be positive. dA by dt, A decreases. As the bird moves, A will decrease. So therefore, dA by dt will be negative. Level of liquid falls, dB by dt negative. Whereas dC by dt will be positive. So where all B dot is there negative, C dot will be positive. This will solve it. Minus 4, V3 equal to, this will be minus 4, minus 5 plus 2, minus 3, minus 4, minus 4, minus 4, minus 8. Okay, speed of bird as seen by fish indirectly. It will see through the mirror. Huh? Speed of as seen by bird indirectly. S4 is equal to first, at what distance the fish is from the boundary? B minus C. Indirectly means first what will happen? The bird is at a distance A minus B. The mirror will see the bird, no? And the bird what happen will appear further. The bird will appear further. So what is the distance of the bird from the boundary? A minus B. A minus B is that one. So apparent height will be mu times of A minus B. And that will be seen by the mirror, no? And its image will be formed. So therefore, this will become B minus C, B plus mu times of. Okay, that's also like this. Okay, I think I'm here like this. The mirror A minus B with the real height, apparent height will be mu times of A minus B. So therefore, this will be C plus B plus. So how you are writing? What is the distance of the fish from the mirror? C. Okay, that one. First, the mirror will form the image of bird, no? And the rays emitted by bird will undergo refraction. So due to that, the real height is A minus B, apparent height will be mu times of A minus B. Then what is the object distance will become mu times of A minus B plus B. This everything is, this will differentiate. C dot, this will be plus 2, B dot minus 2, minus 5, so V4 will be, we'll just do calculation, minus 5 plus 2 will be minus 3, so minus 4, minus 4, minus 6 plus 2, minus 4. I'll make the boundary. I think we have, okay, I didn't draw the diagram only through, since already we have discussed, so I just explained it, okay?